Next up is Joe Cotruvo with Rare Earth Protein Sensor.
Okay. I'm an assistant professor at Penn State and inventor of a technology, a new method to detect and extract rare earth elements. Rare earths are metals that have funny names like neodymium and dysprosium, but they play very serious and irreplaceable roles in a number of technologies, from cell phones to hybrid cars to fighter jets. The value of these technologies is in the trillions of dollars total. Currently, the US gets most of its rare earths from China, not because we don't have domestic sources of them, we do, but because it's not economical to tap those resources. Our solution to this problem is inspired by biology and bacteria, because they solve this every day for a living, and they have the benefit of millions of years to figure out the best solution. And our solution is a protein that we discovered and a sensor that we designed from this protein. And together, these technologies can help with detection, extraction, and separation of rare earths. Current technologies for achieving these ends are inefficient and environmentally unfriendly. Basically, as a testament to just how problematic these current technologies are, the US throws away about $5 billion worth of rare earths every year. And our goal is to basically help us recoup some of those resources. So our technology, in principle, can help out with every step in the rare earth production process, from applications of the sensor to identify new rare earth sources, to streamline the initial steps of the production process, to applications of the protein for more efficient separations, and minimizing the environmental impact, which is great, of the separations process. Our team is myself and one of my students. We discovered this protein and designed the sensor, and we're the experts on how the protein works. And we've teamed up with some experts at Lawrence Livermore National Lab who are experts at developing biotechnologies for metal extraction. And we focused mostly so far on just the discovering the properties of this protein, but we're beginning to start to make prototypes for the sensor and for the extraction systems. Thank you.
So where will you begin? You've got a lot of different opportunities that you mentioned,
Yes.
and how will it work? I mean, you've got these proteins that do certain things. So will they be in a filter that you put in mine runoff? Or, I mean, what's your initial target strategy?
Right. So probably the easiest initial target would be based on the sensor. What we envision is basically a portable method that you could take to the field that uses the readout that we've already shown works in a test tube. Use that as a readout on the presence and the concentrations of rare earths in a particular setting in the field.
So then what do I do with that information? You put something in a body of water or something and it says there's rare earth material here, then what?
Right, so one of the major problems at this point is just identifying sources that have a reasonable concentration of rare earths, such that it would be economical potentially to harvest them. So once you find a site, then that could enable a company to come in and start to develop a mine, for example, at that location. There are also applications in the processing process. So if you have an existing source, there are some pre-processing steps that are necessary to do an initial concentration. And if you could quickly screen through all of the, the tons of material that's produced in that process, that could save an immense amount of time and money over the current methods that are necessary for screening. Ultimately, we would also like to develop the extraction and separation scheme, but I think the sensor is the easiest way into the field, quickest way into the field.
Will you have a number or some matrix that says there's enough here that makes it worthwhile, or will you just have a number?
I don't have a number off the top of my head. In general, at this point, 300 ppm is about the concentration of rare earths that counts as a usable source. Unfortunately, in the US, we don't have very many sources that are that concentrated. That's why the economics aren't working out currently.
So is your current plan then to identify companies that are doing this and license the IP for detection only? Is that what your strategy is?
For the detection aspect of the problem, yes. We're continuing to develop, or we're beginning to develop prototypes for other methods. I think ultimately the money is probably in the extraction and the separations.
So you'll hold
field.
that until you have that process and patent strategy, and then you'll
Yes.
work with that. But initially, you'll start with detection
Yes.
and talk.
Yes.
And did you say you have spoken with companies, or you're planning to?
We're planning to.
Okay.
So again, right now what you have is a protein that makes it easier to detect. So then, if it's the case that 300 ppm, I think you say is a threshold where you start to make it viable for extraction, isn't it that tell me why the detection isn't just going to prove that there's not enough viable for extraction?
Well, if we can more cheaply do the detection, and if we can more cheaply, using a different application of the protein, do the extraction, then that number begins to come down.
Okay, so right now you've proven the detection of it. You're developing the extraction or separation method.
Yes, yes, we've proven that the extraction works in principle, but we need to develop the actual prototype setup that one would use to do that.
So what would the extraction look like? Would it be an open pit mine? Would it be an underground mine? Would it be a filter on a water
The extraction
treatment?
it would be, what we envision is a column that is modified with the protein. The properties of the protein in terms of stability, pH stability, temperature stability, all seem to be excellent as far as proteins go. So we envision a column that basically could be loaded, eluted, and then that process can be continued multiple times.
Okay, thank you. That was the final question.
Thank you.